Okay, this is the first installment in a series of videos I'm calling the Encyclopedia of CV, particularly of CV modules that are used within ZOIA. I think that for a lot of people, these modules are a little intimidating and unfamiliar, particularly if they don't have a background in modular synthesis. And the goal of this series is to try to demystify the modules, to try to make their functions a little bit clearer, and to hopefully, help you unlock the power of these modules, because they're part of what makes ZOIA really so powerful. To that end, I'm using the encyclopedia model because encyclopedias are not exhaustive. They offer a starting point. They're more in depth than, say, a dictionary entry, but they're also limited. So I don't want you to think in any way that this is, the definitive word on any of these modules. But the idea is to try to give some grounding for people who may be searching for it, and to offer some, instances in which the modules can be used in a number of ways. So to that end, for each module, I hope to do 4 things. The first is to explain the module, and hopefully to do that as clearly as I can. The second is to provide, where possible, and this is why number 2 is a little tricky, analogies. So to compare modules to other things outside of ZOIA that you might be more familiar with. Number 3 is pretty simple. I want to make sure that everyone knows about the view function, which uses shift and this little eye up here. And what that does is it gives you a visual representation of what a module is doing at its output. And that can be really useful, I think, for understanding some processes that maybe aren't as immediate to you when you read them in words. So we're going to view the CV output of each of these modules. And then 4, I'm going to try to offer some common and some uncommon uses. So I also want to talk a little bit about this patch that I've set up that I'm going to use as the framework for the series. Along the bottom, there are some modules that are just there to act as helpers. The first is a MIDI CC in module that I've mapped to the mod wheel of my MIDI controller, and that's just so that I can provide easy value changes. The second is a stomp switch, which is momentary, and it's on the left stomp switch, and again, that's just so I can provide a CV change from 0 to 1 without distracting from the module that we're looking at. I also have a value module that's set up to be -1 to 1 for its range, and that may be applied in a number of different ways. I'm not entirely sure I'll use it yet. And then finally, I have an LFO that right now I've set to be very slow, but it's a triangle wave LFO. I'm going to make it speed up a little bit, and we'll look at its output. So, triangle wave, pretty familiar shape, goes up and down. So that's the idea behind this. And then finally, there's one more thing. I've set up a very simple synth voice that I may employ for instances in which hearing an audio representation is useful. It's just a sawtooth wave going into a VCA, going into a low-pass filter. Right now, those are set to be open, but in certain circumstances, they may be closed so that I can show how CV can be used to open or close them. Then the final thing I'm going to add, because people tell me I don't bring this up enough, and I feel a little weird about it, but I don't bring it up a lot, is that if you would like to support the work I do with ZOIA, if I've made videos that are helpful to you, if I've answered questions that have been really useful to you, if you used my patches, I do have a Patreon account, so patreon.com/CHMJakes. My last name's pronounced Jakes, as if there was one Jake and then you met another one and needed a plural. And there's no obligation there. I appreciate it. The money is nice. It's also nice to have support from the community. But no one is obliged to do that. But if it is something that you would like to do, I've set up the tiers to, I think, be pretty reasonable. Let's talk a little bit about the value module. The value module at first does not seem to do a whole lot. I've written out a definition here. What it does is produce constant CV values that are positive or negative. If you're familiar with modular synthesis, you might come across something called an offset or a precision adder. The value module accomplishes the same thing in ZOIA, and all that it does is produce static CV values. Now, a couple of things to keep in mind about the actual value module. So here I have it displaying CV values, but if we click on it, it will display quantized note values, and it'll also display frequencies. These frequencies are the same frequencies used by both oscillators and filters in ZOIA. So you can click back and forth between them, and one advantage there is that it can act as a translator. If you want to know what the CV value of a note is, you can find it and click through, and then you have the CV value of that note. The other thing that you can do, because you have these things, is you can use the value module, for instance, to transpose. If you want to move a sequence by a certain number of notes, you can use the value module very easily to do this. Or if you want to adjust the pitch of a looper or an oscillator, whatever you want, it's really quite useful to have this note output. And the same goes for the filters. If you want to adjust them remotely, if, say, you want to run two filters in stereo and know what frequency you're tuning both of them to, the frequency output is very useful. Now, I'm going to show the only option we have for the value module, which is a 0. The default is 0 to 1. It can also go -1 to 1, and this is where we get these negative values that it can produce. The disadvantage there is that currently, as you click this, it only shows the CV values. Now, I've suggested that it shows the note values, and hopefully that changes at some point in the future so that you can use it to transpose down, for instance, accurately. So that's what the value module does. If we take a moment to look at its output, we see it produces a constant value. I'm going to connect a MIDI controller to it and just adjust. That little hump there is just me changing the MIDI controller. But once I stop adjusting that, it holds a constant value. That's what the value module does. Pretty straightforward. So I've also written down here in quotation marks this other thing, which is the value module is useful as an intermediary for a lot of other CV processes. And I'll go through two of them very quickly. One is that when you adjust the parameter of an audio module, an effect, whatever, directly on the module, you don't have any CV value for that. The module itself doesn't produce any CV value. So if you want to interact with that value, you don't have any way for ZOIA to know what that is. For instance, for setting the depth of an LFO. If you want an LFO to modulate between 0% and 50% mix on a delay, there's no way for ZOIA to know that you've set it to 50% or 0% if you set it directly on the module. But if you do that using a value module, then you can use the CV value that the value module generates to also control the proportions of other modulation and other forms of interacting with that value. So one real advantage of the value module is that you can use it as a remote control. And by doing so, you get the advantage of having CV values for things that you wouldn't otherwise have CV values for. The other way that it can act as an intermediary is because all CV sums at inputs, if we set this back to 0, it's neither adding nor subtracting anything, but we can use it as a hub for other modulation before it reaches a destination. So we can see how that modulation is interacting with one another. And again, use the output of the value module to produce things like sending it to a comparator to find out when the sum of multiple modulations goes high. We can send it on to the destination. We can send it a lot of different places. So it's a useful hub for other CV modulations, a place where you can sum everything together without affecting the output of that sum. So that's why I've described it as an intermediary. One way that value modules are also useful is that they can act as macros. So for instance, if you have a synthesizer with 4 voices and you have ADSRs for each of the voices, you can go and you can adjust each of those ADSRs one by one, changing the decay stage, or you can combine them all into a macro with a value module and adjust all 4 of them at once in the same way, using the same CV values so that they're all the same. And so that's a huge time saver. It's a way to consolidate controls. I like using value modules to create a control page where I have links to other parts of the patch, but I can go through and adjust the things that I really want to adjust very quickly. The other way to use them as a macro would be something like if you wanted the rate of a flanger to increase as the mix of a reverb went up, you could send it to 2 different types of modules too, or get way more elaborate than that. And you could change the connection strength so that the rate of the flanger didn't increase as quickly as the mix of the reverb did. So value modules are pretty simple, but because they're so simple, they become really valuable as ways of controlling a number of things in the same way with precision, or as intermediaries that allow you to monitor and affect other modulation. They also can be useful in the -1-to-1 setting as a way of remapping things that may not have a -1-to-1 iteration. So LFOs, for instance, have a -1-to-1 modulation, but ADSRs don't. And in fact, you could map something onto a -1-to-1 value module that would only go from -1 to 0, which isn't quite like inversion. It would look different than inversion, because inversion, if you start at 0, the inverted version will also start at 0. Here you're more subtracting -1 from everything. And so it's a different type of inversion that may be useful to you in different modulation approaches or for creating logic setups, that sort of thing. So the value module, what it does is pretty simple, but because it does what it does so well, and because it has so many different ways of being of service for that simple, precise, predictable behavior, it ends up being an essential module that you will find yourself using a lot as you work with CV. So we're going to talk about LFOs. And I thought I'd begin with an auditory example. That was just a square wave LFO modulating the filter of a synth voice, because I don't think LFOs are something that I really need to explain. If you've ever owned a guitar pedal, if you've ever owned a synthesizer, you have come across LFOs. These have to be the most familiar of all of the CV modules. You might know them by some other names, but as soon as you hear them and see what they do, they become familiar. So the LFO is the thing that modulates the sound of a chorus or the depth of a tremolo. It's the thing that creates, these sorts of filter effects. So I'm going to operate under the assumption that for this module, pretty much everyone has a good understanding of what it does. I'm going to focus more on the different features that are available for LFOs in ZOIA. So if we look here, we have a number of options, and we have different wave shapes. I'm not going to go through each and every one of them, but there's a good assortment. Now, beyond that, we also have some controls that are really quite interesting. The first one I'm going to look at is the swing control. And the swing control is a little bit like a duty cycle. It's a little bit like a sort of waveform deformer. It depends on the wave itself. So with the square wave, it functions a little bit differently than it does the other waves. The square wave, it'll control the pulse width of the square wave modulation. That is how much of the time it spends at 0 and how much of the time it spends at 1. So when it's at a 0% swing amount, it spends equal amounts of time at 0 and 1. As we start moving this into the negative, it spends more time, if we look here, at 1 and less time at 0. As we start moving it into the positive, we find we have a narrower pulse width where it spends less time at 1. This is important because the gate length, that is the high signal that is received at the gate input of a sequencer, determines the length of the output of gate tracks. So if you've ever wondered how to adjust the gate length of a sequencer to get longer or shorter notes, the trick is to use the LFO, the square wave LFO, as your gate source for the sequencer, and then to adjust the swing amount. Now, the square wave, like I said, works a little bit differently than other waves. I'm going to look at a sine wave now. I'm going to connect a MIDI controller to the output. We see here as we start to move this around, it deforms the wave. So here we have a pretty normal sine wave. As we push it a little bit, we get a sort of swung sine. But as we push it even more, it takes on sort of a shark tooth character. And eventually we look here at 100% swing, or 100.0 something swing, 100 swing amount, It just holds a static 1%, CV value of 1. So this is useful because if we look at modulating this amount, I'm just wiggling my mod wheel back and forth, we can create some pretty interesting modulation just by using different swing amounts. And as we push this into the negative, it'll start to do the same sort of thing, but the other way around. So the shark tooth wave gets turned around, the swung sine gets turned around, and it keeps getting more and more deformed. You know, toward the end, it takes on almost a very wide square wave signal. So that's the swing amount. I'm just going to disconnect these now. And it does different things for different waves. Real quickly, I'm going to show you the ramp wave. So normally the ramp wave forms a steady angle and just goes, you know, up and down. Here, as we change the swing amount, it becomes almost dented, and as you turn this positively, it takes on a sort of a humped character. As you push it more and more, you know, that becomes more and more severe until it looks like a hockey stick. And then finally, once again, we end up with a pretty much static CV value. So the swing control is a way to explore some other modulation shapes that are available just within the options for the LFO. And I'm not sure people spend a lot of time playing around with them, but there's some really interesting shapes that can be found there. So the next option is its range, from -1 to 1 or 0 to 1. And that just means how it will modulate in relationship to a CV value. So from -1 to 1, it'll use the CV value or whatever value a parameter has as its minimum, and it'll go up and down from there. From -1 to 1, it'll use that as a center point and circle around that. So that's just two different ways to approach how you modulate something, whether you want to set a center point or a minimum and maximum. The maximum would be set by the depth or connection strength of the LFO. For input, we have tap, which it should be noted anywhere there's tap, that can also be MIDI clock. And tap can come from, this is a stomp switch. I can tap in a new rate. Or I could use another LFO to control this. If the control is set to CV, I can also modulate the rate, which can be interesting. Down here I have a triangle wave LFO. That's just sort of a utility module that I'm keeping down here. And if we, that's pretty fast. We adjust this connection so that it doesn't go haywire all the time. This is set to -1 to 1. Sorry, this will appear more interesting. So as we set the CV rate, we can affect how the wave is shaped. We look at a different shaped wave. We get some interesting modulation by modulating this amount. Because as this is rising, it rises at different rates. And we get these, Hershey's Kisses sort of shapes out of the modulation that happens between the two LFOs at the rate. We can obviously use an LFO to control other destinations on the LFO or other sources of CV. So we can also use it to modulate the shape. You get some interesting modulation alternatives. Just going to delete this module. So the final thing I want to look at is the phase input and the phase reset. These are somewhat related. The phase reset, if we look at a sine wave, there are different phases of the wave. So when we change the phase input, we change which part of the wave it starts at, whether it starts at the top or the middle or the bottom, whether it's falling or climbing when it restarts. So I'm going to connect our stomp switch again, and let's look at the output. Let me slow this down just a tad. And I've connected the stomp switch to the phase reset control. Each time I press it, it resets to its starting position. Now, one thing to keep in mind with both the sine and the triangle wave is that I think for a lot of us, we imagine these waves actually beginning at 0, right? When I draw a sine wave, if someone asks me to draw a sine wave, I begin at 0 rather than at 1. So in order to achieve that, we actually need to adjust the phase amount or the phase input up to 180 degrees, right? So this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then it's back to 360 or 0 degrees at each of those hash marks, roughly. I'm not the best drawer. So now, when we hit our phase reset, the wave begins where we want it to. And the reset can be useful for a lot of different things, particularly where you want modulation to begin at a certain point. So, for instance, if you want the wave of an LFO to restart every time you press a MIDI key, so that it's tracked to those presses, you need to use the phase reset. Now, the phase input is useful in a lot of different ways. One is if you want your sine wave to look like how I draw them, which maybe you do or maybe you don't. And again, that applies to the triangle wave too. The triangle wave begins at 1 rather than 0. Another option is that you can create LFOs called quadrature LFOs, which are LFOs that are all linked to the same clock but begin at different phase points. And the advantage there is that you can create dense modulation without that modulation getting in the way of one another. So you could have 4 sine waves where one begins at 0, one begins at 90, one begins at 180, and so on. And so at any given point, one of those sine waves might be rising while the others are falling or, at their high point or whatever. And the effect is that it keeps the sounds from overlapping on one another in a way that becomes, overbearing or tedious. It creates a very pleasant modulation because there's always something moving, but it's not all moving in the same way. It's not all building or falling at the same time. Something's rising, something's falling. It's like a gently rolling sea. And you can use phase amounts that aren't, divisible by 90 degrees to create different sorts of quadrature LFOs or LFOs that are at different phase amounts. So then they can have the same clock source, the same rate, so that they're all moving in sync with one another, but they're not necessarily building upon one another in a way that becomes, tedious or overbearing. So those are the options for the LFO. I'm going to stop with just one other thing, which is, again, I think the options that are available for the LFO make it a pretty powerful modulation source all on its own. And to show that off a little bit, I'm going to use the LFO to only patch itself as a modulation source. So we've got a sine wave here. I'm going to lower the speed a little bit before I do this, right? We've got a sine wave. What happens when we use the sine wave to affect its own rate? Well, we get this sort of peaked waveform. I'm going to run it through our synth. This is almost like what would happen if you ran it through a multiplier. And in fact, it is sort of multiplying against itself. We can also adjust the swing amount to make it swung more. Now it's almost like a sawtooth. Now it's almost like a square wave. So even within a simple sine wave, as we patch it within itself, we get a lot of different modulation shapes, a lot of different modulation options. And I think that, again, these different modulation options really give a lot of flexibility to the LFOs and really give you the opportunity to explore some different wave shapes, that are not the traditional LFO wave shapes without getting into, super complicated patching. You can get into super complicated patching and mix and, do all sorts of different wave shaping on LFOs. But even within the module itself, there are a lot of really neat ways to affect the wave shape beyond, choosing from the familiar waveforms. So that's the LFO. The LFO has a lot of uses. It'll end up showing it up in some other installations, and I'll talk then about its specific purpose at that point in that instance. But this is one of those things that I think we're all familiar with. I just want you to be aware of the different ways that you can choose options that give you options for using the LFOs within ZOIA.